So in this video, what I want to do is to study the integral of the tangent function, and I would like you to try to calculate it and then to verify your result by differentiation. So you know how the tangent is defined in terms of sines and cosines, so have a go with pen and paper, and then when you come back I'll go through the solution and give some comments upon it. Okay, welcome back. Let's look at the solution. So here is the integral that we're trying to calculate, and remember that the definition of the tangent function is the sine function divided by the cosine function. And to perform this integral, what you need to spot is that the numerator is up to a minus sign, which we can always sort out, the derivative of the denominator. So this is an example of a general formula that we can recall, which is that the integral of the derivative of a function divided by the function integrated with respect to x is the logarithm of the modulus of the function plus an integration constant. And rather than worrying too much about this exact rule, I'm just going to write down what the answer is going to be. So here we go. We have the integral of the tangent function with respect to x is equal to, now the function in the denominator is the cosine function, so therefore my guess as to what this is going to be is that it's going to be the logarithm of the cosine function, modulus of the cosine function plus some integration constant. And as ever, I've left a little bit of space in front so that we can put in minus signs or numbers if needed. So if we differentiate this, what will we get? Well, we're going to be using the chain rule. We're going to get the derivative of a logarithm is 1 over the argument. That's 1 over a cosine. Excellent. And then the chain rule says you multiply by the derivative of the argument, and the argument is the cosine. So what we do is you differentiate cosine, and that gives you minus the sine of, and the argument of this is just x. And again, in principle, you multiply by the derivative of x, but that's just 1. So what we would get is minus, because the derivative of cosine is minus sine, we get minus sine divided by the cosine. And we've got plus here. So that's easy to fix. We just put a minus sign in front. Now, you could say that that's the answer, but remembering formulae with minus signs in it tends to perhaps to be a little bit trickier. So it's easier to use the rules for logarithms. So if you've got a minus sign here, you can always use it to take the argument of the logarithm here and put it as its reciprocal. So in other words, what I'm saying is if we've got logarithm of a to the n, that is n log a, or viewing it the other way around, n times the logarithm of a is the logarithm of a to the n. And here, this number is minus 1. The logarithm is multiplied by minus 1. So what we have is that the integral of the tangent of x with respect to x is plus the logarithm of the cosine of x to the minus 1. Now this is really dangerous notation, so let's be very careful about it. I'm going to put this all in brackets to the minus 1. I do not put the minus 1 here because that means the inverse cosine function, which is often called arccos to distinguish it from the reciprocal. And this notation means we have the cosine all to the power of minus 1, or 1 over the cosine. And because this is so clunky, we have a special notation for it. I'll just add the integration constant. So therefore we have that the integral of the tangent of x with respect to x is the logarithm of the modulus of sec x, the secant function, which is the reciprocal of the cosine function. And that is our answer for the integral. Now, on the next slide, what I want to do is to go through what you get if you differentiate this to show that you get the tangent back again. And I'm also going to talk a little bit about the relationships linking secant and tangent and which ones I think are important to know. But now you should have a go, if you haven't already, at differentiating this and showing that you obtain the tangent. So on this slide, what I'd like to do is to differentiate our result for the integral, and I'm going to do it in two different ways. So first of all, I'm just going to look at it as it's the log of the secant, and if you're differentiating a log from the chain rule, you get 1 over the argument of the modulus, so that's 1 over the secant of x, multiplied by the derivative of that argument, so that's the derivative of secant. And if you know that the derivative of sec is sec times tan, you can write this straight down, and then you see that the secant on the bottom and the secant on the top will cancel. You will be left with a tangent, and therefore the derivative of the log of secant is the tangent, and that's exactly what we expected because we've just argued that the integral of the tangent is the log of the secant. So we're very happy. If you don't remember the derivative of secant, then another way of doing this would be to say, well, the log of the secant can be rewritten as the log of the cosine to the power of -1, and then we take the power outside using the rules for logarithms. So we have minus the derivative, I've just pulled the minus sign through the derivative, of the log of the cosine. And then again we use the chain rule, minus sign is there, times 1 over the argument, so that's 1 over the cosine, and then multiplied by the derivative of the argument of this modulus, and that's the cosine. And the derivative of the cosine is minus sign. Minus times minus is plus. We're left with a sign, and in the denominator there's a cosine, and sine over cosine is tangent. So again, we're happy. But it's easier if you know this. And what I'm going to do on the next slide is just talk about some of the relations between tangent and secant that I think are important. So on this slide, let's just recall the definition of the tangent, sine over cosine, and the definition of the secant, 1 over cosine, the reciprocal of the cosine. And let's recall this central relationship for trigonometric functions, that the sum of sine squared and cos squared is 1 for any angle. So we'll take this, and this doesn't yet have secants and tangents in it, so let's divide it by cosine squared. That way we're going to get sine squared over cosine squared. Cosine squared over cosine squared is 1, and on this side we have 1 over cosine squared. So this is the secant squared. Secant is 1 over cos. Secant squared is 1 over cos squared. This is sine over cos, all squared, so it's tangent squared. And this is just plus 1. So that is a key relationship. And any time you see tangents or secants, this formula should be somewhere towards the front of your brain. You should be thinking this might be useful. Note, by the way, that this also shows you that secant squared is always greater than or equal to 1, because tangent squared is greater than or equal to 0, and it's plus 1. Okay, So that's a very important relationship, and anytime you see secant or tangent, this relationship is possibly going to be useful. What about the derivatives of tangent and secant? Let's look at the tangent first. So the definition is sine over cosine, and if you differentiate that, well, some people might use the quotient rule, but I much prefer to say that this is the sine multiplied by the reciprocal of the cosine function, and I'm going to use the product rule together with the chain rule. So if I differentiate the sine, I get cosine times the reciprocal of cosine, so 1 over cosine, and then I have the sine times the derivative of this. So the derivative of something to the minus 1 is we bring the minus sign in front. I put it here. We reduce the power by 1, so we go from minus 1 to minus 2. And then we multiply by the derivative of what was in the brackets. So we don't change what's in the brackets here, but we multiply by the derivative of what's in the brackets. The derivative of cosine is minus sine. So we've got a minus sign here and a minus sign here. That's going to become plus. And here we have 1. So we have 1 plus, and then sine times sine, so that's sine squared. And on the bottom, we have cos squared. Cos of x to the minus 2 is 1 over cos squared. So this is sine over cos all squared, so it's tangent squared. So the derivative of tangent is 1 plus tangent squared. And we've just argued that 1 plus tangent squared is the square of the sec function, the secant function. So the derivative of tangent is sec squared. And again, very, very useful formula. And it's the sort of thing that over a cup of tea or a cup of coffee, you can just look at this and you can say, I'll just differentiate it and see how I get that result. Or I can just rederive this formula. Doing things like this a few times is really helpful, and I think it's really good practice to try to look up formulae as little as possible. And every time you have to look up a formula, please try to rederive it. It will help. Okay, so that was the derivative of the tangent function. What about the derivative of secant? So sec means the reciprocal of the cosine. So we are differentiating the cosine of x all to the power of minus 1, the reciprocal of cosine. So we know how to differentiate this. We bring the power in front, that's minus sign, minus 1. And then we reduce the power by 1, so we go from minus 1 to minus 2. We do not change the argument of the brackets, it stays as cosine. And then we multiply by the derivative of cosine, and as we said here, this is just minus sine. Minus times minus is plus. We have sine of x divided by the square of the cosine function. So we have here a sine divided by 2 powers of the cosine. Sine divided by 1 power of the cosine is a tangent, and we would be left with 1 power of cosine in the denominator. So we'll have the tangent of x multiplied by 1 over the cosine, which is the secant. So we see that, as used on the previous slide, the derivative of secant is secant times tan. The derivative of sec is sec tan. The derivative of tan is sec squared. Sec squared is tan squared plus 1. 3 really useful formulae. Now, just to finish the video, remember, every derivative that you know gives you a free integral. So what this tells you is if you integrate sec squared, you get tan, because the derivative of tan is sec squared. Similarly here, if you integrate sec times tan, you get sec, because if you differentiate that result, if you differentiate sec, you would get back to the integrand sec tan. So every derivative gives you a free integral, and we have 2 useful integrals written here. And with that, I'll stop this video.